everybody, this is chapter 2, section 2. There will be a lot of notes here for this, so please make sure you're giving yourself some room to write all these down. Kind of go through it as we can. If I'm going too fast, you can always just pause the video and get caught up. All right. Okay, so these are called conditional statements. Conditional statements are kind of something we use to prove rules. We show that if we say things one way, I might be able to turn it around and it'll have a different meaning, or it might have the same meaning. We're trying to prove things are going to be true or false, basically, okay? In science, we have a thing called a hypothesis. Let's call it educated guess, or we learned the word conjecture last section, and so we're going to look at having a hypothesis. And when you test your hypothesis in science, you're going to be able to get a conclusion. Okay, so a conditional statement is going to start with the word if, and then it's going to hinge, or in the middle of our statement, I'm going to have the word then. Okay, so they're a little hinge, like your elbow is a hinge. The if part is going to be your hand, and the hinge is your elbow, and in between each of those, you're going to have some other words to make a statement. Okay, like if you sneeze, then you have a cold. Okay, so that's an example of what an if-then statement is. If you're in geometry, then you passed Algebra 1. So that's kind of what we're going to look at, all right? So we'll get into that a little bit. Some vocab here that we need to know. The first word is negation, and negation is the opposite of a statement. And so typically we're going to use the word not or no to negate something. So an example would be, if you're not in geometry, then you did not pass Algebra 1. Something like that. Okay. The second term that we have here is converse. And converse, we're going to take our statement that started with the word if and then hinged on the word then, and we're going to flip it. Okay. So remember, the first part of my statement was the hypothesis. The second part of my statement was the conclusion. So to write a converse of a statement, I take those two pieces and I flip them. Okay, so like the example, if I have a cold, then I sneeze. So originally when I said that one, it was if I sneeze, I have a cold. So if I sneeze was the hypothesis, and then you have a cold is the conclusion. Well, now to do the converse of that, I flip it. Okay, so if I have a cold, then I sneezed. Okay, so we'll play with that in a little bit too. The inverse is another term that we have. So we're kind of sticking with our statement. We have a part of our statement's a hypothesis. The other part of the statement's a conclusion. So we're going to negate the hypothesis and negate the conclusion. So I kind of gave you an example of that. I'll do it again. If you're not in geometry, then you did not pass Algebra 1. Okay, or use the one I've been using. If I do not sneeze or did not sneeze, then I do not have a cold. So I have to negate both pieces. Okay. The contrapositive is I'm going to flip and negate the hypothesis and the conclusion. Okay, so an example of that, I'll go back to my first statement. If I sneeze, then I have a cold. So that was what I started with. But to do the contrapositive, I'm going to flip those two and negate both. So if I do not have a cold, then I did not sneeze. Okay, for the other one I got, if I'm in geometry, then I passed Algebra 1, so I flip it. If I did not pass Algebra 1, then I'm not in geometry. Okay. Equivalent statements. Equivalent statements are two statements that are both true or they're both false. Okay. And I think it really could be more than two statements, but we kind of
to have equivalent statements plural, you have to have at least two. So they both are going to be true, or they're both going to be false. And we don't really get into that too much, but we'll kind of talk about it a little bit later on. Okay. All right, so hopefully you got caught up on your notes. What we're going to do here is we're going to take a couple of statements and we're going to put it in if, then form. Okay, we're going to write a conditional statement. Okay, so the way I write it and the way that you might write it or interpret it, it could be different. We just need to kind of get the same meaning going on. So somewhere in here, I'm going to have to stick in the word if and then find a place to hinge it with the word then. Okay, so 2 points are collinear if they lie on the same line. Okay, so I'll just kind of give you an example here. If 2 points, and I'm going to abbreviate just because I run out of space. If 2 points are collinear, then they lie on the same line. Okay, so I think that's pretty easy. I hope you understand it. I hope it makes sense. But I took a kind of a generalized statement, but then put it into an if-then form, which is a conditional statement. So we got to make sure that we get if and then in our heads means conditional statement, all right? I don't know if there's really, when you do these, you can add words, you can delete words from the original statement. Obviously, you're going to add the word if and then into it, but you want it to sound right, grammatically correct. So you can add some words here and there to make it a little bit more understandable sometimes. Okay, and you notice I didn't really flip the order. I could have flipped the order. If points are on the same line, then they are collinear. Okay, I could have said that too, right? But I put it in if-then form. Okay, and to be honest with you, if you go back to some of that vocab we just had, here was my original conditional statement. Well, this is the converse. I took this first one and I just flipped it. I took the two pieces and flipped them. Because remember, the if part's the hypothesis, then part's the conclusion. All right. Okay, so the second one, I'm going to let you kind of play with that one. Go ahead and take that statement and put it in if-then form. All right. So you can hit pause if you want and go ahead and do that. And then I'll give you my version. Okay. So if a number is divisible by 9, then it is also divisible by 3. Okay. All right. Now let me say this. That's a true statement. If any number is divisible by 9, then it's divisible by 3. So 9 is divisible by 3. 18 is divisible by both 9 and 3, and so on. Okay. But let me flip it around. If a number is divisible by 3, then it's also divisible by 9. And we're looking for whole number answers. So let me say it again. If a number is divisible by 3, then it's divisible by 9. Well, that's not really true. Okay, because 6 is divisible by 3, but it's not divisible by 9. Okay, so when we flip these around and start playing with converse and inverse and contrapositive statements,
Some of them are going to be true and some of them are going to be false. Okay. All right. Example number 2, if you could write that one down. If x squared equals 16, then x equals 4. I want to find a counter example. We learned this in section 1. We want to find a counter example that would make that false. So 4 squared is 16, but is there something else that makes it false? So hopefully some of you guys are smart. -4 squared also gives you 16. Okay, so I've been able to prove that this is false. Okay, if an angle is acute, then it is 30 degrees. Okay, so remember acute. If we go back to our first chapter, we had angles that were acute, obtuse, and right. Okay, and the definition for acute is that an angle is going to be less than 90 degrees. Okay, now technically that's true. 30 degrees is an acute angle, but basically, if you really understand how we're going to do these as we go along, it's saying the only way an angle can be acute is if it's only 30 degrees. Okay. So if an angle is acute, then it's 30 degrees. Well, I can say an angle is 45 degrees. It's still acute. I could say an angle is 60 degrees. It's still acute. Okay? So I've come up with something to make that not true. Okay? All right. If we come down here, we want to counter the converse. Okay? So if you guys go ahead and write this out, we have to do a lot of writing in this chapter, so if you could write that down, I think it'll help you understand your notes better when you study them. Okay, this is a conditional statement, by the way, that we're starting with. Okay, it's in if, then form. This is your hypothesis. This is your conclusion. Okay? If a person lives in Sacramento, then he or she lives in California. Okay? Well, you know, really that's true. I think there are some other cities in the United States called Sacramento, but you know, basically that's true. If a person lives in Sacramento, then we're going to live in California. I'm not going to kind of split hairs with there. I think there's like 2 other cities in the U.S. that are called Sacramento. Okay? But it says counter the converse. Now, if we go back to our vocab, converse. Okay? Converse, I'm going to flip the hypotenuse and the conclusion. Okay? Or hypothesis. Hypotenuse is a triangle. Hypothesis and the conclusion. Okay, so by magic, I'm going to do that. I'm going to get rid of this other stuff so we don't get confused. Okay, so I'm going to take the hypothesis, I'm going to take the conclusion, and it's not going to sound perfect either. We could change some words here when we flip it. But if a person lives in California, then the person lives in Sacramento. Is that converse true? And it's not. You know, we live, you know, you guys and me and everybody else that's watching today, you know, some of us are from Placerville, some of us are from Camino, some of us are in Swansboro, and all these places are in California, Pollock Pines. Okay. And other places around here. Those places are all in California. If you really read this and understand it, if he or she lives in California, or if a person lives in California, then the person lives in Sacramento. Well, I can live in other places in California. Okay, so that statement as a converse is going to be false. All right. Okay. Example 4, what they're going to want us to do here is to take this and do all the flipping and stuff. So we're going to write the inverse, we're going to write the converse, we're going to write the contrapositive. So you kind of need to use your notes. Here's my if-then statement. If the measure of angle A is 30 degrees, then angle A is acute. Okay? Then angle A is acute. Sorry. Okay, there's my hypothesis. Here's my conclusion. Okay, so we're gonna rewrite it. So remember, inverse means I negate. I put a negative connotation to the statements. Okay, so if measure angle A does not equal 30 degrees, then angle A is not acute. Okay, so I got to make sure that I negate both pieces, or the hypothesis and the conclusion. Okay, if the measure of angle A is not 30 degrees and angle A is not acute, is that true or false? Well, if it's not 30, it could still be acute if it was like 27 degrees, or if it was 88 degrees. That's still going to be acute. Okay. Converse, I'm going to take my hypothesis and my conclusion. I always kind of go back to my conditional statement, and I go from there. So the converse is going to be, I'm going to flip these two pieces. If angle A is acute, then measure of angle A is 30 degrees. Acute, it has an E on the end. Okay. Sorry about my writing there. Apologize for that. Okay, so that's false. We kind of already talked about that in the previous example, all right? If it's acute, then it's 30 degrees. Well, it could be something else, okay? Contrapositive. We're going to go back to our conditional statement, and we're going to flip it. Now, remember, if you go back to your notes, contrapositive is flipping it, so it's like doing the converse, but then I negate it also at the same time. Okay, so really what you could do is go to the converse. It's written the way it should be. I just got to put the word no or not in there to negate it. So if angle A is not acute, then measure of angle A is not 30 degrees. Okay, now that's true. If it's not acute, then it can't be 30 degrees, okay? All right, so writing, a lot of like English class right now, and being able to understand these different terms. You have to study these guys, and you have to know what a conditional statement is. You have to know that a conditional statement is made up of those two pieces, a hypothesis and a conclusion. Okay, it's going to be important you guys get this down. Okay, we got 5, 6, 7 postulates here about points and lines. Okay, so we'll read all these. Most of these we kind of already have done from last chapter, but through any 2 points there exists one line. Okay, a line has to contain at least 2 points. If 2 lines intersect, then their intersection is exactly 1 point. Okay, let me draw that really quick. Here's a line, they intersect. They're intersecting at 1 point, because if you remember, a line is made up of a bunch of points. It doesn't matter how many, it has to be at least 2 though. But if it's made up of a bunch of points, or it's got that width, then the intersection point, or the intersection of that, is going to be a point. Okay. A plane contains at least 3 non-collinear points. Okay. That's like the corners basically. If you're, remember, we got to kind of define what a plane is. A plane actually goes on infinitely, but we got to know where that's at. Okay, number 10, if 2 points lie in a plane, then the line containing them lies in the plane. Number 11, if 2 planes intersect, then their intersection is a line. Okay, so you guys probably need to kind of write those down. So that'd be a pause it and write it down and then get to them. Okay. All right. Example number 5. What we want to do here is we want to take these postulates we have up here and read the statement they give us in these examples, and then figure out which one goes with which question. there is exactly one line that passes through points A and B. So going up and looking at these 7 things, which one would it be? And it would be number 5. Okay. Lines M and N intersect at point A. So which rule would that be? Taking a look at that. So this one should be number 7. Okay. All right. Sorry, I got to scroll up. Hopefully you got them written down. C, points A and B line in plane P. So line N, which contains points A and B, also lies in plane P. So which rule would that be? And it would be number 10. Okay. Right. Through any 3 points, there is a line. For example, number 6. Actually, why don't you guys write these ones down? So I'll give you a second to do that. Okay, we want, are these statements true or false? Okay. Remember, to make it false, I need to have a counterexample, and I only need one. So any 3 points, there is a line. Well, can't I have a point here and a point here, but can't I have a point here? Can I draw a line through all 3 points? And I can't, so that's false. If 2 planes intersect, then their intersection is a line. Now that one's pretty tough to draw, but use this example that we got up here. Here's a plane P, okay, and then here's a plane Q, and they are intersecting on that line. So think of the 2 planes as pieces of paper, and I intersect them. What's the intersection going to be? It's going to be a line. So that's true, and I'll give you a clue. That's a test question right there, and something that comes up a lot. Part C, if AB equals BC, then B is the midpoint of AC. Okay, true or false? Well, it could be, I could draw AB, or AC, I'm sorry, and put B here and say that they're both the same. Well, that means that B is the midpoint, okay? But can't I draw, some of you guys are not going to like me after I do this, can't I draw something like this, where that's A, and this is B, and this is C, and say those 2 are equal? But B's not a midpoint. B's got to be on a line, and this obviously is 2 lines intersecting at point B. Okay, so that one's false. All right, okay. I think that does it for this section. Hopefully you got that. Please study. There's a ton of stuff there you got to have, so make sure you study. All right, take care.